Okay, so now we're going to focus on the reproducibility aspect of Snakemake, and here I'm not talking about necessarily reproducibility in terms of sequence of steps to perform an analysis like a pipeline, but reproducibility in terms of controlling what software is being used to run each of the steps in our Snakemake workflow. And so, like in every session, here we have three things that we're going to work on in this specific lecture. The first one is going to be reproducibility. The second is using scripts from other languages. And finally, also very briefly, we're going to talk about the case of using an unknown number of inputs and outputs. So the way that we're going to go over those, the first one will be by integrating our workflow with Conda or Mamba and Docker and Obtainer. The second one is through the use of two new directives called run and script. And then finally, for the third one, we're going to show you about the input functions and checkpoints. And so let's focus on the first one. Those of you that were in the courses today will know what Conda is, but just in case to set clear same ground for everyone, Conda is a dependency manager, is it's open source and it's cross-platform, and it allows us to have a control over what software packages and versions are going to be used when we want to execute a certain script, for example. The way that this works is that these different the software is available through different channels, which are repositories for software, and there are different channels depending on the field. For example, you have Conda Force that is having a lot of stuff for general computation, but then you have BioConda, which is much more specialized on bioinformatics. The way, just very briefly, the way that you specify an environment in Conda is through YAML files that look like the one that we have here on the right. And you can specify things like, for example, the name of the environment, the channels that are going to be used, or the dependencies. And so in this case, when you create a Conda environment with this YAML file, it would be named Python-env. It would use the Conda Forge and BioConda channels to install Python 3.12 or higher and Pandas 2.2.3. And so that would be a way to have a controlled environment where we know that the Python and Pandas version are what we want. Now, probably you've done this independently where you say Conda create blah, 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 and then Conda activate your environment. With Snakemake is extremely, extremely simple because it has an integrated package management with Conda. And the way that this works is that within a rule, we use the Conda directive. And the value of this directive is going to be a path to a YAML file that specifies the environment that we want to use. And this path is going to be relative to the rules snake file. So if you have a specific rule snake file that is sitting somewhere in a directory, you need to specify the path to the YAML file with respect to that. Now, the cool thing is that then to tell Snakemake that it needs to use Conda when it's executing the workflow, you have to do very little. And in fact, you have to do something different depending on the version of Snakemake that you're using. If it's version 7 or earlier, you have to use the -- use Conda param or argument. And if you have the version 8 or later, you do the -- software deployment method or SDM, which is the one that we've been using in the course, and then you say Conda. And once again, what this is going to do is tell Snakemake, look through the rules. If there is any that has a Conda directive in there, get to the YAML file, use the YAML file to create an environment, and when the jobs for that rule are spawning, then activate the environment and run the code for those rules with the software that is in those environments. Now, similar to Conda, we can also integrate Snakemake with containers, not necessarily only Docker, but other types of containers. And it works in a very similar way than with Conda, actually. So we have a directive that instead of Conda is called container. And the value that this directive will have is either a URL to a publicly accessible image file or a path to an image location like a CIF file, for example. Now, this handles both Docker and Aptainer images, and we mentioned this before. You can either set a global or a rule-specific container. So if you use the global, in the case here at the top, this will specify that all the rules in the snake file should use the container that is in the specified here. If you use the rule specific, this is going to tell Snakemake that the code for this rule should be executed using this container. And you can combine it. So if you have a global and rule specific, you will use the global for all of the rules that don't have a container, and you will use the rule specific for the rules that do have a container specified. And similar to the Conda case, you then need to tell Snakemake that it needs to use Aptainer to deploy those containers. And that is done differently again, depending on the version of Snakemake you have. So in version 7 and earlier, you do -- use singularity. In 8 and later, you do -- SDM Aptainer. And once again, this is going to tell Snakemake, check if there's any containers. If there are, pull them, and then use them to run the code that is required. Even more interestingly, you can actually combine both Conda and Aptainer. So you can have some rules that have Conda, some rules that have Aptainer, and then you just have to say -- Conda Aptainer. And then Snakemake will use Conda for the rules that have Conda and Aptainer for the rules that have containers, which is pretty neat. I think that it really simplifies the whole process of having a tight control over your dependencies. And then finally, something that is also very interesting, if you have a workflow that is based on Conda, so if you have Conda in the different rules, you can actually use the -- containerize option here, and then this will print to the terminal an actual Docker file. And so you can just redirect that into a file. And this you can then use with Docker build to build a container that will have all of the software required for your entire workflow. So then you can ship this to, for example, Docker Hub, and that simplifies the process. Yes, Tessa.
Yeah, I was wondering, with the last thing you just said, does it also contain Snakemake?
No, I think it will only containerize the dependencies, if I'm not wrong. But Antonin, do you know for sure?
Sorry, no, it won't contain Snakemake.
Right, so it only takes the dependencies. The Snakemake is not inside the image that you will have, so just the software, let's say.
Because you need Snakemake to actually deploy the container.
But you can, in theory, you can do it the other way around, right? You can have a Conda environment that has Snakemake in it that then.
Yes, so that's actually what we're doing on the cluster, on the server.
Okay. Yeah.
So it becomes a bit of an environmentception with
Yeah.
an environment, like an environment with Snakemake that then run a workflow that calls Dockers or environments with stuff in them. And yeah.
Because you guys are highlighting it here in these slides, like we have problems sometimes with Snakemake versions, so it makes more sense for us to do Conda and then download a specific Snakemake version and then use it. So,
yeah, indeed.
All right,
indeed.
thanks.
Exactly. Yeah.
Right. So some of you may be wondering what is actually best for when I want to control the environment that Snakemake is using. And our opinion here is that just use both, whatever works for you, depending on the rule. In case that, I don't know, you just, for whatever reasons, don't have the time to develop an image if you need it and there is nothing on Docker Hub or whatever, just have, even in a rule you need Conda, use Conda, and if in a rule you need a container, use a container. They are both very valid options, really. The only things that we do recommend is that you try to modularize a bit these environments, unless you have a very small workflow. And so similar that we have with the Snakemake files, where you try to put different files containing rules that have similar functions. you try to do the same with the environments. So for example, as Antonin said before, if you have a set of rules that are for QC, have all the rules for QC in one Snakemake file and have one environment for that Snakemake file, for instance. But what is important, of course, to keep in mind is that once you start having multiple environments going on, make sure that they are not going to give problems with each other, so that there are no version conflicts between the softwares that are going to be in the different environments. Right. So with that in mind, then we jump into how we can actually use scripts from other languages with Snakemake, and that brings us to the directives run and script. And so there are two different ways to execute external code in Snakemake. One is the directive run, the other is the directive script. And so we're going to go first with the run. And this is a directive that is going to substitute the shell directive and allows us to execute Python code directly from the Snake file. So for example, you see here, this is literally Python code. And we can even access the directive values and the variables like in the shell with a slightly different notation. But for example, here we have the input square bracket 0 or the params.line. So we have the two different ways of accessing values of the directives. Now, this is nice, but it comes with some problems. For example, if you have a very long code, this will make the Snake file very cumbersome to read, which is not so nice. But more importantly is that when you have the run directive, you cannot have a Conda or container directive in that rule. And that is simply because of how Snakemake is actually going to run that code. It just does not have a way to activate a container and run that code. It's an internal thing. Because of that, we actually recommend that you use the script directive. And this, once again, will replace the shell or the run directives, but allows us to actually execute code from multiple different languages like Python, R Markdown, Julia, Rust, Bash, etc. We will also actually, even if it's a separate script, we will also be able to access the directive values and the variables. And the value that this directive should have is, once again, a path to the script, and once again, relative to the rules snake file. The advantages of that are, of course, that if we have a long code, now it's sitting in a different script, which makes it nicer because conceptually we will say, okay, this rule executes this script. And if you want to know better what that script is doing, you just go into the script. But once again, more important is that then we can actually use the Conda and container directives, which are extremely important for the reproducibility part, of course. And you may be wondering, when it is an external script, how do we actually interact with the values of the directives? And so here is an example for a Python script where we will be able to obtain the values of these directives with this type of notation, where you say snakemake point, and then input, for example, square bracket 0, which would give us this value here, a snakemake output square bracket 0, which would give us this value here, or we can also, once again, use the named notation, so snakemake.params.lines, and this will give us this value here. And similarly in R, we could do the same. So in this case, this creates, if I'm not wrong, an S4 object that you would have different slots for the different directives. And then each of these slots will contain a list for the different values. So for example, you have snakemake add input, that's this directive, and then square bracket, double square bracket 1 because it's an R list, and 1 because it's R and R is 1 based. Similarly for the output, and then for the named example, we say snakemake add params, and then $lines, and then the first element of that. So that's how you would interact with it in the two different languages. Right, and so now finally we go into the last part that is a bit more advanced. We semi-hinted at it from one of the questions, and is how to deal with the case that where we have an unknown number of inputs or outputs. So it can happen that we have cases where we just don't know what is going to be the number of inputs or outputs. for example, when the input files depend on wildcards, for example, or when the number of input files is hard to determine. And here's where it comes the example that I mentioned before. So imagine a case where we want to make a pipeline that allows us to process both single-end and paired-end data. And you will know that if you have single-end, you will only have one FASTQ file per sample. If you have paired-end, you will have two FASTQ files per sample. So this is a very specific solution here, but a way that we can do this is to have first an intermediate rule that will take either one or two files, depending on whether we are at single or paired end, and we're gonna concatenate them so that we end up with one file, and then this one file will be used throughout the rest of the workflow. But how do we do that? So in the rule merge file here, if you see, we have an input that looks different than what we've seen before, and that is an input function. And the way that we use that is that we define this function above of the rule that we want to use it in, and this function will only take one argument, and it's going to be wildcards. Now, when we use this function in the rule, it's important to put it here without parentheses. And what's going to happen is that, and what's going to happen is that when we call Snakemake, depending on the value of the wildcard, something is going to happen in this function. So in this case, we have a function that takes the wildcards. Type is going to be taken from the wildcard value, which is specified in here, if you can see. And then depending on the value of type, we're going to either return a single FASTQ file, that's for the case of single end, or a list in any other case. So in this case, we are asking for a file called results not single end.txt. That's going to mean that type is going to be equal to not single end. And so now we come here, type is not single end, which means that we fall into the else clause, which means that we return two FASTQ files. Just also to make it clear, we can return, for example, a list, but we can also return a dictionary, and then we can put here unpack parentheses and the function name, and that's going to allow us to use the named notation in the placeholders. And then finally, also remember, or just so you know, that functions are going to be evaluated before of the workflow is executed, and that means that we cannot use them in the output. Good. Yes, there was a question.
Is this not single end file an empty file that you only need for the file name?
Wait, can you repeat, sorry?
If this file that you're giving as input is not se.txt, this is only needed. It's an empty file, and you only need that for the file.
No, this is just going to be. This is once again. This is a very specific example, but this is going to be a value that is going to be one of the targets. So in this case, we're asking for a target that is going to be this. And in this very specific example, we're going to end up with a concatenated file.
Yeah, you're right. Okay,
but otherwise, this would come from the rules that are underneath. This type would have to be propagated.
Yes, true. Yeah.
And I see some other raised hands.
Can we define multiple options somehow? Not just so a couple of things layers here. So options for the overall workflow, which rules to run and which rules not to run, maybe. And then options on rule level, like multiple conditions that instead of running in this way, take this and that.
So to the first question, I would say no, because the rules that are going to be run or not are based on how the DAG is resolved. So even if the DAG resolves that a rule needs to be run, I don't think you can tell it to not run this rule. I don't think that is possible. The second question was?
Basically, rather than defining the parameters, that's where I'm heading. Rather than defining the parameters within the rule, you export them as options to the user, so that when I run the analysis, I decide which are the options or which are the parameters that these tools can run with?
Mm-hmm. Mm-hmm. Do you have a direct answer, Antonin? I'm thinking in the meantime.
You can, but I'm not sure that's the best way to do it. But you can define variables that are available everywhere in the workflow. So you can use this, but I'm trying to think of a situation that would require to do something like this.
Example with the mapping thing. So we know what the workflow looks like, and it's a standard regardless which genome you are using. But for example, based on this run, you are analyzing Drosophila. In the next run, you are analyzing a human. So you need, for example, to specify the option. Although you have defined all these references in the config file, I believe that would be the right way. But as an option for the workflow to run, you would say, this workflow, I want to analyze Drosophila. So make sure you pull the right options, so to say.
I think then maybe we'll do something like Antonin said before, of having, before you even run the Snakemake, have something that generates a config file based on whatever settings. I don't know if that's what you were going to say, Antonin.
So this, or you can have sub-config files, like we mentioned before, and saying, okay, so this is a human sample, use this genome of reference. This is a Drosophila sample, use this other genome of reference, and so on. Because it's easier when you know in advance what you want to do. Like if you know which, like in this case, reference genome you want to use, if you already know the annotation file you want to use, you can easily specify it as a config. It's much trickier when you have to work with input functions or checkpoints. When, for example, you don't know the number of inputs, outputs, and so on.
Yeah, I mean, sometimes too much is too much, I agree, but when you design things start blow up, so to say, during the design. Thank you.
Well, yeah, I can share you a workflow, a realistic workflow I wrote, which kind of deals with this problem. So in case you want to have a look.
That would be great. Thank you.
Good. Then the last thing that we were going to talk about is when you have an unknown number of inputs and outputs. This is something that in Snakemake lingo is known as data-dependent conditional execution or checkpoint. So actually checkpoint is going to be a keyword that you're going to use instead of rule. So just to give you an example of when that could happen, imagine that you have a certain data set and you have a rule that is going to run some clustering on that data set and is going to output a file for each one of the found clusters. You can imagine, of course, that the number of found clusters is going to depend on the actual data set. And so you don't really have a way to know how many files are going to be produced afterwards. So this is the case where the checkpoint keyword becomes very useful, because what this does is that it will evaluate the DAG until the place where the checkpoint appears, and then it will run all of the jobs until that point. Then the checkpoint runs, and once the checkpoint has finished running, it will then look at the outputs of that checkpoint, and it will reevaluate the rest of the DAG to figure out what is it that it needs to run. And this is a bit, let's say, the conceptual part of how it works. Implementing it is a bit complicated, and it can be a bit counterintuitive at the beginning until at some point it clicks. But just so that you know that it exists and that it's a bit complex. So we're now going to head into the next exercise. We're going to continue working in our RNA-seq pipeline. And in this session, we're going to focus on the usage of an input function, the usage of R and Python scripts, and also to run a rule inside the Conda and inside a container environment.